we're not using it in that sense here, but yes, that is one place where you see it. We're basically just looking at any fractions here. So first of all, if I'm talking about fractions, you need to know some terminology, not because I'm going to put vocab on the test, but because I'm going to say these words and you guys need to know what I'm talking about. So the rational expression is just when we divide two polynomials. The numerator is the top of the fraction, the denominator is the bottom of the fraction. Right, when we are dealing with rational expressions, we're going to talk about a couple different things. The first thing is domain. Do you guys remember what domain stands for? You've heard that word a lot. It's asking what can x be. So if we have an expression with x, we need to know what values of x are possible. So the domain is everything that makes it defined. Now, if I'm going to type it in my calculator, I don't want to get an undefined. When we're dealing with fractions, that means that the bottom of the fraction can't be 0 because we cannot divide by 0. What we're going to do is look at some fractions and make sure we can identify the domain. If, for instance, I gave you let's say x plus 6 times x plus 4 for x plus 2 times x plus 4. If I am asking you to find the domain, the biggest problem that I usually see is people look at it and they want to go ahead and cross out the x plus 4 because it shows up on top and bottom and give me the domain of the final answer. What you have to remember, domain is based off the original problem. So when I'm asking for the domain of this, it's before I reduce it. Domain, we usually say capital D. And for now, what I'm going to have you do is just tell me what x cannot be. So x cannot equal. So if I'm looking at this, all we look at is the bottom. If you have two things multiplied, the only way to get 0 is if one of those things is 0, right? So I need to know what makes x plus 2 equal 0 and what makes x plus 4 equal 0. And so what do I get? I'm sure you guys can do that. Subtract over the 2 and we get -2. Subtract 4 and we get -. So my domain is x can't be a -2 or a -4. Because if it's either one of those, when I plug them into the problem, I get 0. Is that one okay? So this problem, we need to be able to write our fractions in lowest terms. So if I'm looking at that, before I can cancel anything, things have to be multiplied together. Right now I have terms added and subtracted, so I can't actually cancel anything out yet. That's where our factoring comes in. So we're going to factor top and bottom. What numbers multiply to 4 and add to 4? Okay, so that's x plus 2 and x plus 2. All right, on the bottom, what multiplies to 2 and adds to 3? All right, so now, what do we see? If I wanted to write it in lowest terms, what can happen? It is an x plus 2 squared. When you're dividing, once it's multiplied together, if the same thing's on top and bottom, we can reduce that, so we can cancel out one of those x plus 2's. And we end with x plus 2 over x plus 1. That's my lowest form. But I also asked for the domain. So domain is telling me what x cannot be, and that is based off the original problem before you cancel things out. So I have to think back to this denominator. What can x not equal there? -2 and -1, because you say each of those equal to 0. X plus 2 can't be 0. X plus 1 can't be 0. Okay, do you guys know where I got that domain if I don't show my work for working it out? Okay. Any questions there? Alright, let's do another one. So if I'm going to write it in lowest terms, or even find the domain, I need things to be factored. What would you do to factor the top?
Just GCF.
GCF, we can take out a 2. Okay, on the bottom. Multiply to -12, add to -4. I see. Okay, can you tell me the domain right now? Right. X cannot be a +4 or a -3. Just so you know, on the Math Excel, it will have it set up as a solution set, so it'll say like the set of x such that x cannot equal and just have a blank. You just have to type in the 4 and the -3 there. To reduce, does anything cancel out right now? Not yet, because nothing is written, or we don't have any parentheses in common. Am I getting an email from somebody or something?
You should. I was getting rewrapped.
So are there any parentheses that are close to canceling? Yeah, when I look x minus 4 and 4 minus x, what's the difference? Flip-flopped, the negative. So what we could do is go back and take a negative out of the top. If you take out a negative, then it's a -4 plus x. Is -4 plus x the same thing as x minus 4? Yes. So now those things cancel. So my lowest form is -2 over x plus 3. That's how my fraction reduces. Domain, based off the original, is telling us what x cannot be. Is that one okay? Let's do, I want you guys to try one. Let's say we have x squared plus 3x minus 10 over x squared minus 25. I want domain and lowest. So on the top, multiply -10, add +3, plus 5 and minus 2. On the bottom, difference of squares. So my x plus 5's canceled. My lowest form is x minus 2 over x minus 5. Can I cancel out these x's? No, you can only cancel when things are multiplied together. So that's my answer. Domain, you can do capital D for domain. What can x not equal? Right, you can list them out separately, you can put plus or minus 5, either way is fine. Remember, it's based off before you cancel anything. Are there any questions about domain or reducing fractions? Okay, let's talk about multiplying and dividing with fractions. Our goal with these is to make life as easy as possible, okay? Let's not create extra work for ourselves. So if I'm going to ask you to multiply a couple of these rational expressions, we want to cancel out as much as we can so that we don't have a really big polynomial to factor and reduce later on. So our goal is going to be to factor and reduce first, then do the multiplication problem. So let's say I gave you this one. So we're just going to multiply and leave our answer in factored form. If I just start multiplying here, there is going to be a whole lot of distributing going on. And I'm going to end up with like x to the 4th, x to the 5th, and then have to turn around and try to factor that. And it's going to be hard. It'll be a lot of work. But if I start with my original problem and I simplify first, it actually saves me a ton of time, and the problem isn't very complicated. We are going to factor one thing at a time. So if I look at the numerator of the first fraction, what multiplies to 1 and adds to negative 2? Negative 1, negative 1. If I look at the denominator of that fraction, what can we do? That one's a perfect cube, x isn't, but what do they have in common? X. We can just take out GCF of x. That leaves x squared plus 1. Does x squared plus 1 factor? No. Alright, let's look at the next one. 4x squared plus 4, what can we do? GCF. So if it were a minus, we could do difference of squares. Because it's plus, we can't, but we do have a GCF of 4. What about the denominator? Multiply to negative 2, add to positive 1. What would that be? Now, this is all multiplied together. So if anything shows up on both the top and the bottom, we can cancel it, whether they're in the same fraction or different fractions. So for instance, I see x squared plus 1 here on the top and over here on the bottom, so I can cancel this because it's multiplied. What else can I reduce? We can cancel out one of the x minus 1s. My direction said to leave it in factored form. So on the top, we just multiply straight across. So we just have 4 times the x minus 1. On the bottom, I'm left with x times the x plus 2. You could certainly distribute, but usually I'm just going to tell you to leave it factored because it's just extra work to multiply it out. I just want the simplest fraction here. So if you factor first, A, you have easier things to factor. B, a lot of stuff is going to cancel out. What did I give you this one? It looks awful, but look at this. This is just telling me I'm dividing two fractions. Okay, we could very easily have the problem written with a division sign. It just means the first one divided by the bottom. So the problem could be written either way. The question is, how do you divide fractions? Multiply by the reciprocal. Right. If you're confident, you could go ahead and start factoring on this step. For this first problem, I'm going to write it out so you see exactly what I'm doing. So I change it to a multiplication, and I flip the second fraction. Now it's just like the previous problem. So we factor. X plus 3, does that factor at all? No, so I just leave it. I'm going to put parentheses around it just so I remind myself I can only cancel that if I have another x plus 3. It has to be that whole thing. Denominator, x squared minus 4. What could we do with that? Alright, the next one, x minus 2. Can we do anything there? Nope, so we just keep it. Denominator, how do we factor that? Flip them so we get a negative in the middle. So minus 4 plus 3. Right. What cancels out? Anything else? If there's nothing left on the top, what do I put? It's just a 1. It's like if anything was divided by itself, it turns into a 1. And then on the bottom I have x plus 2, x minus 4. Alright. Doing okay? Can we try a couple more together and then I'll give you guys a couple to try on your own? Same directions. We're just simplifying this and writing it in factored form. So we start factoring. 3x plus 6, what can you do with that? GCF, take out the 3, we have x plus 2 left. 5x squared. Really nothing you can do. If you wanted, you could write x squared as x times x, but that's just a personal preference. Over here we have an x on top, so nothing to do there. X squared minus 4 would break into x plus 2, x minus 2. What cancels at this point? The x plus 2. Is there anything else?
X.
We can actually drop out a plain x. You have 1 here and 2 on the bottom, so you take one of them out. So the x on top is gone. There's only 1 left on the bottom. So now we're left with 3 on top. On the bottom we have 5x times x minus 2. Let's go ahead. We'll do this one. Remember, this just acts as a division. If you want to divide fractions, keep the first one the same, you change your division to a multiplication, and you flip the second one. Then we factor. What can we do with x squared minus 4? 2x plus 4. Two, and the denominator 3x minus 9 has a GCF of 3. Alright, what cancels out? If you just multiply this right now, 6x times 2 is 12x. On the bottom, I have a 3, an x minus 2, and an x minus 3. What do you notice about that? Look at our coefficients. Can we reduce 12 over 3? That turns into a 4. You might have caught that sooner. Up here, 6 and 3 could reduce. But just don't forget to look at your coefficients as well. Those can reduce. All right. Questions for me? Can I give you guys, I don't know, should I give you the homework or should I give you problems to try? 15 minutes. Okay, I'm going to put 2 problems up. You're happy. Here are your 2 problems. Take a second and try them. A, you might have started reducing some things, like you can reduce a 2 and an 8, you can reduce a 9 and a 27. Most of people, I think, were just straight multiplied to start with, which is also totally fine. If you didn't reduce, if you just multiplied, you get 54 y squared over 72 y to the 5th. And then you just have to reduce here. 54 over 72. If you're not sure, you can always use your calculator, depending on which kind you have. If you have these, remember when you put it in, you just have to hit math number 1 if you need the fraction out of it. Turns into 3 over 4. Think about our y's. If we have 2 on top and 5 on the bottom, what do we end with? 3 on the top or bottom? Bottom, because there were more there to start with. If you had reduced first, you could have started canceling out things here and said, okay, well, 2 and 8, that would leave a 4. 27 divided by 9 is 3, and work that way as well. On B, for the numerator, we do have to slip and slide. So if I get z squared minus 16z plus 15. What multiplies to 15 and adds to negative 16? Divide our 5 back. So we get 5z minus 1 and z minus 3. Denominator, what multiplies to negative 12 and adds to positive 1? Positive 4, negative 3. Can I go ahead and flip this fraction? Okay, so when I flip it, this denominator is what's coming up on the top. I have a GCF of 2z squared. And that would leave a z plus 4. When I flip, this goes down the bottom, and I could take out a 6z, which leaves 5z minus 1. So just factoring everything, and we have been practicing factoring. So now we cancel anything that shows up. So I can drop a 5z minus 1. I can drop a z minus 3. I can drop a z plus 4. All we have is 2z squared over 6z, which can reduce. 2 over 6 is 1/3. 2 z's on top, 1 on the bottom, just leaves a z on top. Okay, so make sure you're watching coefficients that reduce as well. Do we Have questions, sir? So we have about 10 minutes. There is a Math Excel assignment open, but you will notice the deadline isn't going to be yet. It's one assignment for both today and Tuesday. So Tuesday, we might practice a couple more of these just to make sure you're okay, and we'll also do some addition and subtraction. I think you can do everything except maybe the last 4 or 5 questions on the Math Excel or addition and subtraction. The rest are what we've been doing today. So go ahead and start it, but you don't have to finish it yet.